In this demo, we're going to look at resonance. Here are resonance reeds, so these masses are on a slight pole here, and each of these has a natural frequency. So if you get them to move, they will move at a certain frequency as a result of their mass and the length of this. So what we're going to try to do here is to see what happens if you push on one. It's now moving back and forth. It's connected through this rod to other objects that are next to it. So let's see if we can get this to drive this. So that's the idea of resonance here. So if I push on this, let's make sure they're not moving. And let's get this one to go. So this is going back and forth at a certain frequency, as you'll notice, and that is being transferred through this onto this object right here. And you can see it's also now moving at the same frequency. So they're essentially the same, so they have the same natural frequency. So this is driving this now at the same frequency. The other ones are not moving, right? Because they have a certain frequency, a natural frequency, and this frequency that this is oscillating at is not that natural frequency. So they are not moving, but then the one that actually has the same frequency will move. So let's try another one. Start off with them not moving, and let's try to get this one going. What you should notice is that this second object, right? So the one here is now going to move back and forth, trying to match that same frequency. None of the other ones are moving because, again, the frequency of this is matched by this. So none of the other objects have the same natural frequency, so they're not going to move. So these resonance reeds are an example of driven mechanical resonance.